And this is the Mechanics Homework Booklet question 4. Part A, we're simply asked to plot a graph of all the data. The marking points here were for having sensible scales on both axes, for examples, not going up in threes and using at least half the space in both directions. The second mark is for the points being correctly plotted within half a small square. The third mark is for a straight line until at least a stress of 2.5, so that's there, times 10 to the 8. You're meant to know that this should be giving us a straight line and then a curve. Okay, we've got kind of funky wiggles going on, but a straight line section, stress strain curve for a ductile material. So they're the three marks for the axes, for the plotting, and for a straight line until at least it was this point here. In part B, we're asked to use the graph to find the Young modulus of the metal. Well, Young modulus of a metal, straightforwardly, is the gradient of the stress strain curve from the straight line section. So we've got to take points on there. We've got to find the gradient of there. So we've got a mark for use of Young modulus is the gradient, and we've got a mark for the value. Somewhere between 0.90 and 1.1 times 10 to the 11 pascals. If used, because you should be getting it from the gradient, you can only get the marks if you've taken data from the table, if they came from the point which the line passes through. If it's from a point that's not perfectly on the line, maximises out at 1 mark. So for example, if I'd have taken that data point there, which is just off the line, and put it in, that would have been 1 mark, not 2. See then, we've got a 3 metre length of steel rod. It's going to be used in construction of the bridge. The tension in the rod will be 10 kilonewtons. The rod must extend no more than 1 millimetre. Calculate the minimum cross-sectional area required for the rod. Well, Young's modulus is stress upon strain, so F upon A divided by delta L upon L. FL upon A delta L, rearrange that, and A is FL divided by the Young's modulus times delta L. Put in the data, there's 10 kilonewtons, there's the 3 metres original length, there's the Young modulus, there's the 1 millimetre. If that's a maximum value, because it's on the bottom, that is going to give me a minimum area, and that works out as 1.6 times 10 to the minus 4 metres squared. No specific marks for significant figures there, so you're okay having too many significant figures. So that's the Mechanics Homework Booklet question 44.